Hey y'all, I'm David, and this is Lab 1 Constant Motion for Physics 2211. Okay, so the purpose of the lab was for us to gather data on the observed position and time of an object that we had moving at a constant velocity, and then compare it to a calculated and coded model. The fundamental principles we were focused on in this lab were Newton's first and second laws. The first law states that the speed and direction of an object will remain constant unless it is acted upon by an outside force. And the second law states that an object's acceleration is directly proportional to the net force acting on it. The models that we used for the most part were the position update formula and the velocity update formula. The velocity update formula was studied, I guess, in its absence because we were looking for no change in velocity. Yeah, so here's our raw data. As you can see, the line is pretty straight, so we have a relatively constant motion. And yeah, our experimental procedure. First we took a video of us rolling this marker at constant speed. We used the tracker app to like track the motion through different points in the video. And then we coded using the average velocity and made our graphs. So for the coding, basically all that was changed from the like starter kit we were given is I gave the ball a velocity vector in the x direction. Uh, and we changed the time to line up with how long the video was, and then use the position update formula. And here's what we got. So the line is completely straight. Our velocity is completely horizontal. It was constant throughout the entire time. And the position update formula, as you can see, we have our position over time. Yeah. Okay, so here are the two graphs overlaid. Um, as you can see, they look pretty similar, which is good. It means that our experimental data had an almost constant velocity, and the velocities are like almost exactly the same. The two lines are pretty parallel. And this calls back to Newton's second law. Our net force acting on our object was zero, and therefore the acceleration was zero, so it continued moving with a constant velocity relative to the calculated values. Um, our sources of potential error were friction and air resistance. This is because we ignored those for the purpose of the experiment, but they are still there. And then also human error in how we slide the marker and how well you track it on the tracker app. Okay. What if we were to flip the plus x and minus x axis? So if we did that, the graph would still have a straight line. There would still be constant velocity, but the graph would be downward sloping instead of upward sloping. Is it possible to say how many pushes and pulls are being added together to give net zero force? Uh, in this case, it's not possible. Um, this is because in the real world we have constant forces from many outside sources at all times. Like we have the gravity and normal force, and then there was also friction, air resistance, etc., that we just ignored for the purpose of the experiment. But it's not possible to say how many pushes and pulls there are total. Uh, in conclusion, we our data lined up pretty well with Newton's first and second laws, uh, and those were the two being tested.